Hi everyone, welcome to Kavi's lecture. In this lecture, I am going to teach you how to eliminate left recursion in the context-free grammar. It is one of the important steps in construction of top-down parser. Now we will see the general form. General form of left recursion grammar production is capital A, that is non-terminal, produces the same non-terminal capital A. Rest of the production will be alpha and beta. Rule 1 to eliminate this left recursion is A produces beta A dash, and rule 2 is A dash produces alpha A dash or epsilon. By using this rule 1 and rule 2, we are going to eliminate the left recursion in the given grammar. Now I'll tell you what is this A, what is this alpha, what is this beta with an example. Now consider this example. E produces E plus E or E minus E or ID. Before going to solve this problem, I'll tell you what is this E. E is a non-terminal. In a context-free grammar, all the capital letters are termed as a non-terminals. All lowercase letters, symbols and numbers are called as a terminals. Okay. So here capital E is the one and only non-terminal. Plus, minus, ID. These are all called as a terminals. These are termed as a terminals. Okay. In a context-free grammar, left-hand side will be a single non-terminal. Now I'll tell you when you will call the production as a left recursion. Now see this, left-hand side non-terminal is your capital E. Similarly, right-hand side production is capital E. When a non-terminal E derives the same non-terminal E, then it is called as a left recursion. This needs to be eliminated, which means that we are going to change this grammar into an equivalent another grammar such that this left recursion is going to be eliminated. For example, here E produces E plus E is having a left recursion. Similarly, E produces E minus E is also having a left recursion. We have to eliminate in both the production. Now we have to compare this production with the general form. Now in the place of A, we have the non-terminal E. Hence our A is E. Then what is the alpha? After whatever you have, this A will be termed as a alpha. So here after this E plus non-terminal E will be the alpha. Similarly for this production also. So this is E produces E minus E. This E will be termed as capital A. And this minus E will be termed as the alpha. That is, whatever the production which is having left recursion, the remaining will be termed as alpha. But now you see this production E produces ID. Here there is no left recursion. Such a cases, whatever you have here, that will be considered as beta. So now what is your beta? ID is your beta. Now simply apply this rule to the given production. What is A? E is your A now. What is your alpha? Here we have two alpha. One is plus E, another alpha is minus E, and beta is ID. So now as per the rule 1, now write down the solution. E produces, what is your rule 1? A produces beta A dash. What is your beta? ID is your beta. Okay. Then we have to introduce dash to the start symbol. I mean the non-terminal which has the left recursion. Here our E has a left recursion. So write the E and introduce the dash. By applying the rule 1, you will get E produces ID E dash. Similarly, apply the rule 2. What is your rule 2? A dash produces alpha A dash or epsilon. Now apply the same. E dash produces, what is your alpha? Here you have two alpha. One is plus E, another one is minus E. So write plus E. Then as per the rule A dash. Here it is E dash. Another production is minus E E dash or epsilon. Now the given production E produces E plus E or E minus E or ID has an left recursion. By applying the rule 1 and rule 2, we have eliminated the left recursion. Now look at this production. E produces ID. Here it is a terminal. Here there is no terminal, non-terminal named as E. So here there is no left recursion, we have eliminated. Similarly here E dash is another new non-terminal which is used for eliminating the left recursion. Here you have plus. So there is no left recursion. Similarly for this production also E dash produces minus. So all the left recursions are eliminated from the given grammar. I hope you can understand this. Thank you.